Hello there, I'm Roman, software engineer and game development enthusiast. I'm currently working with Godot and developing a game called Rocketschmeers, which is a jump and run racing game. It focuses mainly on multiplayer, and since there is a lack of bigger examples of multiplayer games in Godot or best practices, I started kind of my own journey. And I've been asked on the Facebook group to do a small tutorial about the things I discovered. So first things first, in order to get a connection to another player, we of course need some sort of menu where you can set an IP and a port. This is all for LAN games. So I'll demonstrate it. I've got a client already running here. So I'm starting server, then connecting over there, and then the game starts. So as you see, the state of each player is synchronized. I got some power-ups. You can jump, run, and well, the main goal of the game is to get to these monoliths and be the first one there. So in this small tutorial I will just show you how to synchronize the state of the players. Okay, so game's terminated. Well, how did I do it? I got my menu scene, and this is the main code of it. So the scene itself isn't very that special. The magic starts with the start server pressed here. So I got my netcode in a separate script. I'll go into that, and then I just basically create a server, and that's it. And for the client, it's more or less the same. I got my netcode, got the IP from the front end and the port, and I joined the server. Okay, what does the netcode do? The netcode, yeah, for the connection you need a port, of course, client port and server port. In this case, the client port isn't really needed, so I can actually close it, but the server port is needed. Okay, so in order to create a server, first I save my player info. This is the local player, me as a server. All the player info is right from the menu. In this example, it's a fork of my original game. It's just the player name. So, where do we start? Oh, right. Got a host. The host object is the new network multiplayer init object. It's available since Godot 2.2, I think. In a prior version, it's not there. No, there you had to create like your own enet with TCP or UDP connection, well, whatever. Here we use this enet, and we just basically create a server. That's yeah, it's that easy. So then we got to check if we got some errors or not, and in best cases we just go to our main tree and set our network peer, which is the host we here created. So much for the server creation. The client connection looks similar. Joint server. Again, we create a new init object, and it's important that we use the same type of compression mode. There are different types of compressions. Won't go into detail in this video, but it's very important that you use the same zlib in that case. So and then you instead of creating a server, you create a client, join the connection, and again set your network peer to host. So what happens if a client joins the host? Well, there are certain events that are fired. We bind the events here in the ready function. Well, so if a network peer connected, so a player connects, we call this function. Well, they're connected, isn't really that much in there, but the connected OK is what we need. It's only a callback that's been called on the server and only for the client. So if client joins, this event isn't fired on the client side, I think. Not 100% sure right now, but I think it's the way around. So if a player connects, each player gets a unique ID. You can get it there. Well, sorry, I must correct myself. Of course, it's also fired on the client side. Then you get the network unique ID. The server itself, the host, has the unique ID 1 always. It's always 1. So if you ever want to send a message to the host, you send it to unique ID 1. So in this case, the player connects here. He gets his ID, we get his player info, and then we are calling it with a specific function. It's called RPC, remote procedure call. So we're calling a remote procedure that's called registered player, and the parameters for this that we are sending to this function are the unique ID of the currently connected player and his player info. The objects can be quite complex. In our case, it's just, as I said, the name. And then we're calling this registered player. So whereas this function, it's also here. And it has a specific keyword. It's called master. These keywords like master or sync or slave or remote, there I think this 4 that's handling the network stuff, are introduced in the version 2.2. So what the master keyword does here is Godot really supports this master-slave kind of network type. So I got this master host that's getting the messages and broadcast them to all the other players. This is the main idea. The master can also check if the cheats applied or something like that. And a function that's labeled master or marked as master is only executed on the server, on the master server node. The other part is a slave that's only executed at the slave point. So if a player joins and this function is called by a player, it's only executed on the master side, because in my game case, only the master should know which player are joined, and he will start the game when everything's ready. So the player ID is submitted, the player info. We add some status to the console or some message panel, which player joined, and if the total amount of players joined is the total amount of players we are set. This is a fixed number currently in this network demo. You can of course have thousands of players, as much as your server is capable of. In this case, it's just 2 for demonstration purposes. Okay, so if we got the total number of players that we want to start the game with, then create a new array for players done, because there has to be, of course, some preparation. Each player has to instantiate the world and tell the master that he is ready, and when everyone is ready, the game will be started. So all the players that are ready will be noticed in this array. So and then this RPC method is called. It's called preconfigure game. Got two parameters. First one is the level that I want the players to join in, to create, and of course the player info of the player infos, so for players. Okay, then as you see that this method is marked with a sync keyword. Sync means this function, when it's called by the master, is called on every client that is connected. So when we execute this function is tried to be executed on each client synchronously. So we pause the tree for each player. Then we check if there is already a world instantiated, because it could be a map rotation. Then we of course remove the current world. We load the next level that's sending as a parameter. Of course instantiated. We add the world, and then for each player in the player info we create player instances, meaning each player of course exists as a player instance, but not all of this player objects are controlled by the current player, because I want to see the other players. He needs some kind of object which is preloaded here, and each player instantiates an object for the other players in the map. So that's what's done here. And if I notice the player that I'm instantiating is myself, because I'm the server, then I have to set the network mode for that player, because it is the master node. So Godot knows how to handle the communication. If I'm not the server, the master, then I'm setting the mode for that player to slave. Okay, then the player is added to a specific node in the world. Players all organized there. I can show you that. This is all level. Here, players, they're all added there, just for organization purposes. And then basically the whole setup is done, and the player can mark himself as done preconfiguration, as ready, and will be added to the player's done array. Here I have to separate the calls, because as a master I cannot call myself. The done preconfiguration function is a remote function, so basically I can only call it on some other player's system. And when I notice, okay, I'm the server, then I call it directly. If I'm not the server, because I am a slave client, then I just say, okay, here RPC ID, I'm calling a function on a specific user ID's system. So as I said, the ID of the server is always 1. We're calling the done preconfiguration file on the master, and we are sending him our client ID or network unique ID as a marker. So I'm done. I have the ID, this ID, and I'm done configuring. So and then there's a little debug. Okay, if we noticed all players are done, which have joined our game, then again we are calling for all clients sync function post configure game, starting the tree again, hiding our menu, and the game starts off. This is basically just what happens right here in the beginning. So I'm starting a server here, not a name. I'm waiting other players to join. So I'm the other player, I join, and boop, post configuring, and we're ready. Okay, so much for the joining. Well, this was actually the easy part. The harder part was the synchronization of the player state. Well, starting with the world script. The world script basically just starts this overlay right away, and when the overlay is done, hiding all the statuses, and then I set up the players, because right at the beginning I just have to know which of the players that are added into the world are the controlled players. And how do I know that? When I initialize the players, I gave them all a unique ID. Each player object has a player ID of the initialized player, right? Can show you that again. Where are we? Here. Each player got each player's object got its ID. We set also the name that are displayed over the head of each player. So when the world initialized for the player, we just get his unique ID, find then basically the player that should be actively controlled by the current client, and say, okay, here you're active. For direct access later, we initialize the player variable. And then we stop processing because we already found the player that should be controlled. This a little bit game logic. There's nothing really network relevant things here. Okay, so the game started. We got the active player. What happens next? Well, we got here our player. Just go to the top. There is a little bit, of course, game logic and variable things going on here. I won't specifically focus on the network part. So it's fixed process. So UI event, we play some animation, player runs left, right, just the basic jump and run setup. And gravity things. But the most important part for the network is here, when the player first moves locally. So I want to give the player the better experience by first moving on his client and then synchronizing the state to the master, and the master then overrides it. If necessary, if there is some difference noticed and it doesn't make any sense or something. So first I move myself, and then again this is a remote function. So if I'm the server, I say okay, I have to call this move function and synchronize it with the rest of the players. If I'm the server, if I am a client, then I'm sending my status to the server. In this case, it's unreliable. It's another new function, unreliable, because this fixed processing is done so often. It doesn't matter if one or two packages are lost. It can be unreliable just to benefit a better workflow, better gameplay. Because eventually one package will be there and everything will be resolved, and the server will then check if everything's alright and update the state to all the other clients. So as a client, I'm sending it to the server, and I'm sending my position, I'm sending the direction I'm looking in, I'm sending my current animation state and my rotation. So then this function is called. In this case, I'm not doing so much checks, but this is the point where you would check as a server, as a master. Is there anything wrong? Should there be any correction? Maybe somebody's cheating. Does the state make any sense? And correct it. Or kick a player, and eventually we say, okay, everything's right. I'm gonna call this remote function again with the states or corrected states I got here, and it's synchronous. So this function again is called on each client and also on the master side. Yeah, probably a bit redundant if you think it from the master perspective, because he correct his position like twice. But it's just a demonstration. It's a little bit messy still. Right. So this function is called, and the player animation and direction and everything else is set and synchronized on all the clients. Again, if you find it difficult to understand, you have to think of this player object is really an instance in the world. But if it's not me, it's not the player controlled object, this fixed process of course is not called. It's never activated, and the only thing that's happening is the synchronizing of the state to that player object. If the real controlling player sends me the info, I will apply it on that player, and everything happens here. Okay. Well, this is actually pretty much it for the player movement. In another video I will probably show how the states of the other objects are synchronized, like the laser or this wall type of thing that magically appears. I mean this thing. Yeah. Again, to show you, it's also synchronized over there. I can see the player jumping around. Also collect. Oh, there's the laser. The player is also stunned when he hits by the laser. Okay. Well, if you got any questions, you can send me an email. I will probably open source this demo, but I'm not quite sure when it will be the case, because I'm still working on the game, and yeah, a disclaimer at the end. It's probably not all best practice, but it's working for me at the moment, and I'm still kind of figuring out how Godot is handling things. And well, it's as I read in the documentation, this keywords, they will still exist in the upcoming 3.0 version. So I'm pretty confident I will be able to migrate this code in the game without big hassling to the new version. Currently I'm staying with 2.2 because there isn't anything I need from the version 3.0 at the moment. Alright, thanks for watching.